Hello, my name is Vandit Kachar. Today I am going to present our work Per-Vis, Person Retrieval in Video Surveillance using Semantic Description. The main motivation behind our work is in the person re-identification or person search problem. The network takes an image query as input and it finds the similarity between the query image and the source surveillance frame, and based on that the correct person will be retrieved, which has a major limitation in practice as the network requires a query image. Considering the case of a lost person where we only know about the person's appearance, the above mentioned approach fails, and semantic description, however, will be useful in these cases. Based on these limitations, in our work, we studied the problem of person retrieval in video surveillance with the semantic descriptions. The core aim of our work is to use the computer vision techniques to fully automate this task and retrieve the person in challenging conditions by using minimal number of semantic descriptors. Our approach Per-Vis is very simple and straightforward, where it's divided into three stages. First, we use mask RCNN for instance segmentation, a T-SI camera calibration method for height estimation, and semantic descriptors to narrow down the search space for retrieving the correct person. In the figure, as we can see, Per-Vis uses the following sequence of height, torso cloth color, torso cloth type, torso cloth pattern, leg cloth color, leg cloth pattern, and the gender. The main trick to calculate exact real height is to get the head and feet point from the instance segmentation boundaries, and correspondingly extract the torso and leg patches for effectiveness. We refer viewers to look at our work and code for more in-depth information on how these have been done. The dataset we have used is the soft biosearch dataset, which is a well-known dataset for this particular person retrieval task. By using the dataset, we trained the DenseNet 161 model for different descriptors, and the validation accuracy we achieved for the data has been shown in the table. For performance matrices, we use the IOU, intersection over union, where the ground truth box will be compared with the network's generated bounding box with an effective approach, and thus why we surpass the previous approaches or methods by a fair margin. The dataset has been divided into four categories such as very easy, easy, medium and hard conditions, such as different occlusion or background filters. The graph shown in the image represents the average IOU for the 41 test sequences based on the above categories, and we can notice that from medium to hard sequences the approach struggles to retrieve the correct person. We also showcase the localization accuracy for 41 test cases or test sequences. We encourage viewers to take a pause to guess the number of sequences that are considered to be hard or medium. We perform one of the ablation experiments by using different networks for 5 sequences for the different categories respectively, as sequence number 4, 13, 21, 23 and 28, which are considered to be very easy, easy and medium and hard respectively, and which stated the results that we achieved for different networks have shown in the table. And as we can see, compared to other networks, DenseNet DenseNet 161 performs very better than the other networks. Considering the easy and hard sequences, we showcase the network's outcome for each filter. In the filtering sequence, if the correct person retrieved before the ending of the sequence, the approach will not follow the sequence order and provide that person with coordinates throughout the presence in the surveillance footage. We also report the failures of our Per-Vis, where for the medium and hard categories the network struggles to find the correct person and provides the false negative at the end as shown in the images. Thereby, we conclude by mentioning the major benefit of our work, that the selection of this filtering sequence is easily differentiable to other or more dense or small descriptors such as bag, cap or hair type, etc. and where the heavy crowd is present. We notice one of the important use of instance segmentation in this problem, as it allows precise height estimation and patch extraction for torso and leg. We also believe that there is a more work that needs to be done, and the possible future work involves the use of pose estimation, the use of tracking in this particular work, and other descriptors to improve the performance for more real world scenarios. We thank you, we thanks the audience for listening to our work, and we also let them know to feel free to visit our project web page, which is shown in the slide. So thank you again.